Hello and welcome to lesson 4.5, Effects of Changing Dimensions. So first off, we're going to start off with this Minds-On activity. The Minds activity shows that the Great Pyramid of Giza is a square-based pyramid that is 147 meters high and 230 meters long at the base. A student wishes to construct the same kind of shape as a miniature model of it, 1,000 times smaller. In other words, the dimensions are 1,000 times smaller than the original. How much clay is going to be needed to make this model, assuming that that model is not hollow? So, take this time at this moment and pause the video and try this out on your own. Okay, so if you try this out on your own, your height should now be 147 divided by 1,000, or if you wish, as a decimal, 0.147. And your length of the base, I'm going to actually use the letter B, should be 230, divided by 1,000, which is now 0.230. Now, because you're looking at how much clay is needed, you're looking at volume. So volume of a pyramid is given by the formula b squared times height divided by 3. So the base is 0.230. Square that value, multiply by 0.147, take that answer, and then divide by 3. Okay, so now using my calculator, I work that out, substitute it in, and I get 0.0025921 meters cubed clay of material. Now, most likely you probably wouldn't want to round this to 2 decimal places if you're just looking at volume, but you could if you wanted to. You could also rewrite it in terms of its scientific notation as approximately 2.592 times 10 to the negative 3. There you go. Meters cubed of material is going to be needed, and therefore you'll be as accurate as you possibly can. Okay, so what we're going to do today is we're going to see how changing certain dimensions affects the size or the height or the volume or the surface area or the circumference or perimeter of various different shapes. So we're going to start out with a circle that has a radius of 2 centimeters. We're going to see how the circumference changes and the area changes. So first of all, circumference is given by the formula 2 pi r, and area for a circle is given by the formula pi r squared. Let's change this to a different color. So to find out how much times bigger one is to the other, we'll look at the circumference first. So the original is going to have 2 centimeters in length. So 2 pi times 2. The new one is going to have double the radius. So if you double 2, you get 4. So 2 pi times 4. Well, you might notice this is a ratio that you can easily divide out without even having to pick up your calculator at all. So 2 divided by 2 is 1, pi divided by pi, same value, cancel them out. The only thing you're left with is 4 divided by 2. 4 divided by 2 is 2. So if you double a circle's radius, you will actually double the circumference as well. Okay, let's take a look at area. So originally, the radius was 2, so this is pi times 2 squared. And the new one is pi times 4 squared. Well, again, you can cancel out the pi's here. 4 squared, you have to work out first, is 16. 2 squared, which is 4. Then you can work out how many times bigger one is compared to the other. And there you'll see it's 4 times bigger. Okay. So let's try that with surface area and volume of a cube. So surface area of a cube, since there's 6 sides, and what are the bases? You're going to square that. For its volume, it's whatever the base value is, cubed. So what effect does tripling the length have on the volume? We're going to see how many times bigger it is. Okay. So originally it's 1. Afterwards it's triple the length, so triple 1 is 3. Notice the 6's can cancel out. You're left with 27 over 1, which is 27 times bigger. Oh, sorry, my apologies. I worked that out. That's supposed to be a squared. So that should be 9 and 9. So 9 times bigger, actually. Okay, let's look at the volume. This is going to be 3 cubed over 3 to the, oops, my apologies, 1 to the 3. So that's 27 over 1, that's 27 times. So you actually notice that these two bases, 9 and 27, are actually powers of 3, which deals with a tripling part right there. Whereas your first one, you doubled. These two values are double each other, or powers of 2. Okay, so how can we also take a look at this information if we don't actually know what the dimensions are? So let's take a look at this example. The radius of a cone is given by r, and the height is given by h. Show what effect doubling both or either dimension has on the volume and surface area. So let's look at area. Well, the area of a cone, surface area, is given by pi r squared plus pi r s. To figure out the value of s, you need to work out the square root of r squared plus h squared. So we're interested in doubling either both of them or neither one of them. Or just, sorry, either one of them. So let's check out if we double just the radius, let's say. This time what we're going to actually do is we're not actually going to use a value. You could use a value for each one and see how it works out, but we're going to try it with variables. So here, the top part is going to be the radius is doubled. So every time you see an r, replace it with 2r instead. We're going to replace that s with a 2r. Okay, so how many times bigger? There doesn't seem to be any kind of relationship here because of that 2 in the numerator. That's just going to be 4 pi r squared. This is going to be 2 pi r. This is going to be 4r squared plus h squared, which we don't relate in any way. So as you can see, this value is 4 times bigger, but this piece is 2 times bigger, and this one's 4 times bigger. So there's no actual relationship between the two if you just double the radius. If you try doubling the height, you'll find out the same thing. Even if you double both the height and the radius, you'll find out the exact same thing. There is no relationship in doubling the radius and the height, or either one, in volume. In the surface area. However, for volume of a cone is given by pi r squared h divided by 3. This one might have something different. Okay, so if you double just the radius, let's say, you'll notice the pi's are the same, the h's are the same, the 3's are even the same. So the only difference between this one is 4r squared over r squared, which is 4 times bigger. So if you double the radius, you'll see something. Let's try times bigger for just the height. So this time we leave the radius the same, but we double the height. So in this case, you cancel out the pi's, you cancel out the r squareds, you cancel out the 3's. This one, you find it's only double the size if you double the height. And if you can guess, if you wanted to look at the volume, if you doubled both the height and the radius, you're going to see it's 8 times bigger. So there is a relationship between volume, but unfortunately surface area doesn't work. And this is how you can verify it using just variables. And if you just want to see how it affects radius and height. But again, you can also choose it by selecting values. And thus concludes this lesson.